Swayam Prabha. Digital India. Educated India.
Or you use it only to see, for example, cricket scores or something, which is not. Don't access your banking systems. Don't access your sensitive anything else, right? Because there, what will happen is these intruders, they will constantly track what is happening, okay, and finally they will try to make. There are so many things called session hijacking, all those. These are called man-in-the-middle attacks. So they will try to make use of your connection, and then they will get access to the systems. Phishing, we talked about it, and this one, denial of service and distributed denial of service. The goal here is more or less for the corporate world. For example, the intent is to, for example, if a corporate world, okay, I used to work in the matchmaking industry, and before that I was in the internet company, right? You have say 100 millions of users, right? So the intent of the hacker or malicious person is to disrupt the functioning of the system. For example, it could be my competitor, okay. Even today you see national threats. For example, if any other country, for example China or Russia, anybody, right? Most of these hackers are from China, right? Probably they want to disrupt the systems in India. Their goal is to disrupt growth, whatever it could be. So any government website, probably what they will do is distributed denial of attack is more like you send continuous connections. So you have a limited capability in every server, every system, right? It has a set of memory, it has a set of hard disk. Your network throughput is probably 1 GB, 2 GB kind of stuff. Everything is not. So their intent is to attack the system using vulnerable systems. For example, if your laptop is vulnerable, if they have access to your system, they will use your system to send a connection to that server. So this is how exploited systems are used in this world. Nobody buys a server, 100 systems to attack a company. They identify from the internet where and all the systems are available in the world, how vulnerable they can I use this system to send a request to the other side, right? That is the DDoS attack. Again, remote code execution, insecure protocols. For example, as you probably study, you will understand what are the protocols. For example, today there is a mandate that every website has to use a HTTPS, secured HTTP, right? HTTP is a protocol for web, right? So if any website uses HTTP, it is vulnerable, right? Similarly, if you click on that lock button, you will understand more of the certificate, the secure certificate, because we have certificate authority who issues all the security certificates. So as you understand more of these things, for example, there is something called SSL version 1, 2, secured socket layer, right? So now that got replaced with TLS, which is called transport layer security. It is for the systems which are on the two sides of the internet, they have to use transport layer security. So this is more important. And anyway, we talk of viruses, spyware, adware, worms, and the Trojan horses. And the last three are data exfiltration. How I copy my corporate data into my USB drive, right? These are for the corporate world. So USBs will get blocked. You cannot download data. You cannot send data through email, right? What if, like I said, the insider attacks, right? Somebody might download the entire corporate data onto their laptop, copy it to an external drive. They may simply walk away, sell it to a competitor, right? So these are some of the threats. We talked of all these things in the previous slide as well. And what is we talked of this CAA triad also, right? The confidentiality, integrity, and availability. So how do you ensure? Okay, for example, I want to ensure confidentiality. My data is private, it is secret, it is kept. How do you ensure? One way is to use data encryption. For example, your password. Every organization stores password. If that password gets stored in a plain text, it is highly vulnerable. It can be easily guessed. So what they will do is, as the end user types the password in plain text, that password will be hashed and salted, and it will be stored in the encrypted format. Because encrypted data cannot be accessed. Because I don't know what is the encryption algorithm that I use, what is the cryptographic key that I use, what is the length of that cryptographic key. Nobody can assume that, right? So it's very important that you use data encryption as much as possible. Biometric validation, right? Instead of the ID card, right, use your biometric thing or retina scan, which is little more protective than the other step. And two-factor authentication, it has become a standard now. Be it your Gmail or anybody, they ask you, banking system send the OTP. They want you to confirm, right? So these are some of the and security tokens. So you ensure confidentiality by using all these things. Similarly, the availability, I don't rely only on one system. Okay, you back up the data to multiple systems, multiple locations, so that in the event of any fault, you can restore it from there. Power supplies, everything has to be in. When you talk of availability, it's not that about the server that stores the data. For example, if you go to data center room, even in your college, right? What if the power supply goes off? Your systems will crash immediately. So what is my alternative power supply, right? Within the server, do I have a redundant power unit, PDU as they call, right? Do I have a redundant power supply? So everything has to be redundant. Firewalls. So how do firewalls ensure availability, right? When you talk of firewalls, and what does firewalls has to have availability? Because firewalls, every firewall also has to be redundant. Okay, if the primary firewall fails, the secondary firewall will become active. But the firewalls, they restrict. Okay, by restricting the unauthorized access, unauthorized entry into my system, I ensure my systems are available. That's why they mentioned the firewalls. And data redundancy. Like I said, you copy the data into tapes, you copy the data into disk, you store the data into cloud, multiple cloud. So all these things ensure availability. And integrity measures. How do I ensure my data is integrity? You do a constant checksum. For example, you have a Word document, you see it is a 100 KB in size. You send it to another person. What if that person says, I don't find, whatever you send is, I'm not finding it correct. How do you ensure that it is the same file that you send and it is visible on the side? It is like a checksum. Okay, you ensure the size of the file and all those things are the same. Uninterrupted power supply. File permissions. Okay, file permissions is that, for example, you develop a document, you are writing an article, you are publishing a paper, right? And you store it in the department's server. What if everybody has access to that? Because you have worked so hard for a conference, it is there, right? You share it with your department head or a professor or something like that. You trust, okay? They ask you to upload it into this server. But how do you ensure that it is not accessible by everyone? If it is a public access, everybody will have access. So file permissions is one of the way. I restrict, I am the owner of the file, I give access only to these two people. So file permissions is one of the very, very critical thing, and data backups. And some examples of what is it? We talked of these things in brief, right? For example, confidentiality, right? The employee payroll database, it has the salary details of every employee. What if you make these systems available to everybody in the organization? Your friend, probably you are, both of you are from the same college, you understand what is your salary, you understand what is your friend's salary. Either one of you could draw more salary, that's it, right? It's the confidentiality. So it has information about everything. It could be just an example, right? It's just an example. So annual appraisal, you get 20%, the other person get 5%, right? So the sensitivity portion of that is related to the confidentiality. So not everybody should have access to every data. So even if I work in the HR data, right? Can every person in the HR department have access to all the data available? No. If I am the manager, if I am the chief HR officer, I will have complete access to everything. Even within the HR department, again the same thing will come. Manager will know all the details of their subordinates, but the subordinates should not have access to the manager. So it is how you keep all these things, with constraints and everything. Again, the second one is more like from the e-commerce firm. You buy items in the e-commerce site, Amazon or Flipkart or something like that, right? You store your credit card data, you store your personal data, address, who you are, what is your age, because they give you recommendations based on your buying patterns, based on your age and everything. They will come to know what items could you have an interest into next time. So if that data is not safeguarded, again, right, your credit card might get stolen, that information about it. So what are the safeguard measures that you have to have in place, right? So strong authentication. Authentication is the first step, right? You have to prove yourself that I am so and so, user ID, right? When you say the user ID, the system is going to see whether that user ID exists. Second step is password. And we talked of two-factor authentication. Just to ensure they understand that you are the same person, they send you a OTP to your email or mobile to ensure that authentication. So at least this will safeguard my information is safe, not if the other person is accessing my systems. Access restrictions, we talked of it. Not everybody should have the same thing. Steganography. Steganography is more like you hide the data. For example, you have sensitive data. You don't want to send it through email. For example, your friend asks for a password, right? You are on leave. Your friend asks, "Hey, what is the password to these systems?" Okay, you want to send it. You don't want to share it over phone. So steganography is more like hiding the. For example, you embed that information into an object. For example, you have a photo, right? Within that you store that password in some place. You don't know. When you see it, you will see only the image. So steganography is more like it's one of the ways to protect data. Again, we talked of encryption, remote wipe. For example, you have an iPhone, you have everything in that iPhone wallet. You are using everything. Your credit card data, personal data, email, everything is there. You lose your phone. What if somebody gets access to that phone? That's it. They can reset the password. They can unlock everything. So, so remote wipe. That's where in iPhone kind of stuff you have the option of find phone and all those stuff. So immediately you can wipe off the data. At least you are protecting or minimizing damages that can be caused to you or to your system. What if a corporate laptop? A CEO travels. He loses his laptop. In the security side, as he puts his laptop, he loses his laptop. What do? You have to have the remote wipe capability. And finally, this awareness is very, very important. So if somebody is in the corporate world, constant training, constant way. For example, they may even want to send some phishing emails to employees to ensure how many of them are literally accessing that phishing email. Because what is the awareness that they have, right? So training and awareness is very, very important to make sure confidentiality is taken care of. The second part is integrity. We talked about how does my data is genuine, it is correct all the time, right? Banking, again, you are a user, there is a banking system, there has to be a trust. You have to trust the bank so that nobody works in the bank because they do some manipulations of your data or something like that, right? So guaranteeing the second one is the credentials. What if they have access to your user ID and password? They can do, right? So integrity is very, very important and it has to be protected. And you see this when you talk of data and integrity. The data could be in use. You are connected to the online system, you are doing some funds transfer, meaning the data is in use. And transit. Transit is like somebody is taking a backup. So the data is in transit. Or even in this app, it could be static. The data is there in the storage system. Wherever it is, it needs the integrity should be same. Whether it is in use, whether it is in the memory, as I update my balance or I am depositing, right? It is in use. Transit or whatever it is, it has to be completely remaining the same. How can you ensure that the integrity? We talked of encryption. Encryption is the best method to ensure data is not manipulated or something like that. You encrypt the data, nobody can Even if they have access to the system, they don't, unless they have the cryptographic key. And digital signatures. See, digital signatures to ensure that the data is same as it gets transmitted to the other side of the person, right? And you can cross check whether it whether it has the digital signature of the sender, and there is whole set of things. How does digital signatures work? And hashing is like, there is a one-way hash, there is a two-way. There are open source tools. You type some letters, use a hash method that will get, for example, if you type my name is Muguntan and you hash it, you will have a checksum, right? And the hashed thing is one way. You cannot get the original text. So when I type something and hash it, that's how the digital signatures will also work. You send it to the other person. The receiver, what does it do? They can only validate the hashing of that. Okay, this is the text that I said. If they hash it, they also need to get the same hashed value. If there is a change, then they can see the integrity is lost. And digital certificates. Beyond these things, intrusion detection systems. So when we talk about network security, there are systems called intrusion detection systems. Okay, I am the user, so the systems can validate who is the user, who is trying to log into the system, who is trying to log into the corporate net. That's the first point of entry, network, right? So intrusion detection systems are, they use AI nowadays. Okay, they can find patterns, because what is the pattern that they genuinely see? It is called the whitelisting and blacklisting kind of. So if they see a different pattern, even some banking systems or some AI incorporated systems, they can, sometimes I am a genuine user, but I may get access denied to the system. For example, it used to be in the past, right? Banking again is a simple example. I am connected to the banking system. I do some transaction. I am in Chennai. I withdraw something in the ATM or I do some fund transfer. Within next 1 hour, there is an access, say from Mumbai or Delhi, doing a transaction using my account. Is it possible? Unless I have shared my user ID password to my relative or something, it should not be possible. What if there is a transaction happening from US within that 1 hour, 2 hours? So this is where I said corporates or individuals, constantly you have to focus on what are the risks, what could be the possibility of the new threats coming up, right? That's where people design, be it Oracle or anybody. They understood all these things could happen or they are happening. They put more restrictions. It is not possible for somebody to do a transaction now and within an hour from US. I have tried to do that because I was in US, with my son. They immediately gave me a call. Are you trying to do something? They may not know I am in US, right? But this is not possible. Doing a transaction in Chennai simultaneously within the next 2 hours doing from a remote phone. So intrusion detection systems are very, very helpful. And authentication procedures, versioning control, continuous auditing. Okay, deploying technology is one side of things. Unless you do a continuous auditing, continuous monitoring, continuous logging, because you need to do something, because these systems will help you to analyze what has happened, who has access to these systems more frequently, are they genuine users, are they hackers, right? So these systems will ensure the integrity side of things. And finally about the availability, like I said, it's about brand value, right? Why everybody is having Gmail? Because you feel that it is part of your life. Okay, everybody goes to the Twitter when something, you are availing a free service, but then still you are blaming and mentioning something in Twitter saying that Google is not available, Gmail is not available. So availability is all about one thing, it's about revenue loss. If a business which is involved, everybody is in business, meaning that their motive is to make profit, they grow, right? So if the systems are unavailable, then it is like a Uber and Ola. You try to book a Uber and you see that your system is still loading. You don't have that patience of waiting. Immediately switch over to the other use, right? So in a corporate world, it is the same thing. If your systems are not available, if you have more latency, your system is not responsive enough, people are not going to use it. They will switch over to the other vendor. And how do you ensure? For example, that's where, you know, like, sorry. So any small disruption, anything more than 1 minute, 2 minutes, or a website loading in less than 100 seconds, people will like it, right? Milliseconds. If something is taking 2 minutes to load that website, you don't have that patience, right? Like I said, hackers regularly, their intent is to disrupt the website because they want to cause damage. They want to, if some, like I said, a competitor or anybody, they want to cause damage to my system. In that process, my reputation gets lost. I am no more in the business. So a DDoS attack occurs when hackers flood the site with unnecessary requests. Like I said, they will continuously send requests. Their intent is to cause damage. And how do you ensure that these things are taken care? Redundancy. Like I said, if one server has a problem, the other server should immediately take over, so that users don't see any gap in the availability server. Data getting redundant storage. System performance and network traffic should be continuously monitored. So availability is not about data available in the server, it's about network, whether my network is redundant. Like I said, whether my systems can be accessed to a different route. So CIA is the fundamental thing, you know, even if you do, like I said, the certification or CISSP or anything. The questions could be just to share that. Okay, I finished my CISSP. I was longing for it. I have 37 years of experience in IT. Okay, I grew up as a developer in the government side, but I could have returned the CISSP long time back. But as an individual, as a human being, I was still having my own doubts whether I will clear it. Okay, it costs about some $750 or so much. So every penny is, you know, hard-earned money. It's not that I don't believe in my skills or something, but it's an exam again. It's a 4 hours exam, objective type. You cannot go back to the previous questions. So you understand everything. It's all about English. I took it, you know, recently when I was with my son in San Francisco. So the questions could be only in 2-liners, 2-liners to maximum 3-liners. Every word is important. They will put the whole, you know, essence of it in that 1 or 2 lines, and you have to complete 250 questions in that model. So it's not about certification. If you have understood the concepts, if you have real world skills, it could be easy, it could go, because you can go with a 50-50. You have 4 choices. 50-50 is very easy. Out of the 2 options, which is the best? So the questions could go like this: which is the most important? What is the best way of getting availability? And the 2 options will look like similar. So it's all about, not just about knowledge, it's about experience, it's about understanding the context. So that's where I said, you know, context is very important when you talk of cybersecurity. Are you in the corporate world? Are you in the government? Are you in the financial world? Are you in the healthcare world? Context is also important. It's not that everybody has money to invest in redundancy. Hey, my systems are down for 1 hour, my business I am okay, because I can manage the loss. Okay, but if I am a healthcare organization and my healthcare systems are unavailable, I have legal obligations, right? So you have to understand the context, and I mentioned about the certification, meaning that the context is very important. Whether you are, you know, writing an exam or in the understanding of your corporate environment is very, very important. So we talked of the CIA triad, right? Confidentiality, integrity, availability, and one of the ways we talked about is the authentication and access controls. So when you talk of access control, these 2 words you need to remember. The first one is the least privilege. Like we talked about the payroll systems, right? Employee, HR, payroll and all. So users should have the minimum authorization. What is the the lowermost thing that I can give access to? Read only access. Meaning that I will ensure my document doesn't get corrupted or somebody modifies my. So access control, the first principle is the least privilege principle. Even within that, the need to know. Hey, first of all, is there a need for this user to have access to this system? That is called the need to know principle. These are again, you know, useful for your certifications. Okay, you have to raise a question whether this person need to have access to the system in the way. If at all they need to have the access, what is the least privilege that I can give? Read only or write only or read write, whatever it is. So need to know is more granular than the least privilege, and users must have a need to access that particular information before accessing it. So before access itself, you have to raise the question of the need to know, whether the user need to know what is there. So within the access control types, there are so many categories. Okay, the first one is called the discretionary access control. Like you are developing a document, like your conference paper. It is at your discretion. You can define who has access to that document. It is the owner of the document that defines who has access to this, and they can grant privileges like I said, read and write permissions. If you develop, you give access to your friend or to your professor alone, not to everybody. That is at the discretion of the owner. So mandatory access control, it's more valid in, for example, you are in a military. Okay, so in military, you might have heard of top secret, secret, confidential, or unclassified, meaning that certain documents, okay, we have heard of wars, okay, the other country is trying to attack us, so that could be so many documents getting transferred between the departments, or the colonel, general and the prime minister. So in military you might have probably heard of this, or if you are in the government you might have seen confidential. There will be a file which will say confidential or secret, or if you are in the corporate world you might see private, confidential, all those stuff. So mandatory access control is a method. Okay, like I said, this is how. Okay, there are two things. One is about the document, that is about the object. I have a file, that file is classified as a top secret. The other one is the user. The users should have the clearance, like if I am the topmost person, if I am the prime minister, then I will have access to the top secret documents. Okay, so the user should have a clearance for accessing the document. The object also will be classified as a top secret, confidential, or something like that. That is the mandatory access control. The other one is the role based access control, like we talked about the HR, right? I am the manager, I am the chief of HR, I am the recruitment head, right? Based on the role, the access controls will be defined. Who has access to what portion of the database? This is more of a, for example, if you are in the healthcare system, you have a doctor, you have a nurse, you have an administrator. So the administrator will have that is a role. So anybody who has that privileges assigned with that administrator role, they will be able to create a new, for example, some new nurses joining. So the administrator will create the user ID and password for the nurse. So their role is only limited to creation of the users. They will not have access to anything. If I am the doctor, I will have a complete access to the patient's data. If I am a nurse, I will have only access to the portion of the data that is relevant, okay, not to every other data. Attribute based access control. This is what I said. Okay, you go to the next level of access control. For example, I am in US, so that there is an attribute called location. Okay, so based on the location, based on the time of the day that I am accessing the system, so you can define controls. Okay, for example, everybody works 9 to 5 or 9 to 6. If somebody is trying to access the system at 10 o'clock in the night, you can define controls. No one can access the controls beyond these working hours, or from if you are in the office, maybe you can access. If you are outside of the network, you cannot access the control. And finally, there is something called a rule based control. Again, rule based control will involve both attribute based and the role based, right? So there are certain rules. For example, firewalls work based on the rules. Okay, you get a user ID, you get the password, you get the location, right? You have VPNs. You might have heard of virtual private networks. If you want to access your corporate network from your home, right? Then those things are coming based on the rule based. Okay, then it will identify which location you are trying to coming in from or connect to the system beyond user ID and password. So only when all the conditions are met, it will allow you. And this is one of the key principles, like we talked of least privilege and need to know. The same thing is called, this is called the IEEE, identity, authentication, authorization and auditing. Okay. So identification is like, sorry about the slide, not being visible. So identification is about, I am a user, I raise a request to the owner to create a user ID and password for me, so that next time onwards I will share my user ID and password. Okay. So it goes to the owner, user gives a identification and password. So the first step, like I said, your ID card, kind of, that is the first step, identification. You identify who you are. The second one is authentication. You want to connect to the system. Your authentication is you share your user ID, password. If the system will validate the password, like I said, the password is stored in the hashed format. It will not be stored in the plain text, because then it will hash whatever the password that you type, that will be hashed. The hashed password will be matched with what is there in the system. If that matches, then you are authenticated to the system. So after identification, it is authentication. The third one is the authorization, like we talked about the payroll database again. Whether I am authorized to access the payroll system. Okay, if I don't have access to the payroll system, I cannot connect. Maybe I'll have access to my intranet portal to find out something. So authorization is more about access controls we talked about in the previous slide. And finally, it is about accounting. Okay, I am the user, I identified myself, I shared my user ID, password, got authenticated. Then I am connecting to my system. If I am given access controls to access the system, or it could be denied. Whatever is that, it has to be stored. This is called logging. Whether it is successful, my access is restricted or denied or unallowed, that has to get logged. And this log has to be constantly analyzed, because that is where you will get to know who and all tried to access the system, whether that authentication and authorization was successful or denied, then why people are trying to, whether they are genuine users or outsiders, the systems will give insights into all the stuff. Okay, we talked of threats. Anything that could cause damage to the systems or users, we called it as a threat. How does the threat process actually work? Okay. There is a threat agent. Threat agent is like, it could be a malware, it could be a hacker, anything. So the threat agent gives rise to the threats, right? And what does this threat do? We talked of vulnerabilities, gaps in the system, right? My system is vulnerable. I have not used antivirus. I have not used any other, tools and technologies that will protect. So the threat's intent is to exploit the vulnerability in the system, and this will lead to the risk for the entity. So if there is a, if I have not patched my system, that system is vulnerable, right? What is that vulnerability? Not applying the patch, right? So that vulnerability led to my server getting hacked. This is the security risk. And what does this do? This cause damage to the asset, and it can cause an exposure, maybe financial loss of all those stuff. And what do you do that? You countermeasure by safeguards. Apply the patch regularly, right? Or continuous assessment, continuous logging and monitoring, all those stuff. These are the safeguard measures. So this is a continuous cycle. You don't do it once. Every day. That is where systems like SIEM, like I said, systems incident event management, all those stuff. So you have multiple systems, multiple locations. If an organization is spread across the world, like large corporates, right? They have hundreds and thousands of systems, servers, right? Networks, firewalls, everything has. They will have, probably that is where they are using cloud. They cannot store the data in one server. They will be storing data in Google Cloud, Azure Cloud, AWS Cloud, everywhere. All those things has to be constantly analyzed. You have tools and technologies that does real-time monitoring, real-time assessment, all those stuff. So risk assessment and understanding of the threats is very, very important in the cyber security world. And probably you might have heard of API, right? Application Programming Interface, right? Because you don't want to develop everything on your own, okay? So now everything works in the API world, okay? You have an API, you make use of the API, you make a call to the other side. For example, I'll give a simple example, okay? So in my previous organization, the matchmaking industry, so people will upload their photos. How do you validate it is your photo or they are not using any celebrity's photo, right? Because people have their own apprehensions, right? But in that process, the system has to validate whether it is a misused photo of somebody, right? And there is a set of database that is because only known celebrities photos will be there. Tomorrow somebody may become a celebrity, that is it. But do I want to develop a system to do that facial recognition? It will take 6 months or 1 year also for me. So what I will do, facial recognition software is available in Amazon facial recognition or in Google. So what I will do, as soon as the user uploads a photo, I will make use of an API call, send this photo to the other side, get it validated. It is not a celebrity photo, I request a call back, right? But again, these are some of the top 10 API security vulnerabilities, okay? You may not want to go into everything. But again, broken object level, insufficient logging and monitoring, injection attacks we will talk of, right? Functional level broken thing, security misconduct. So everywhere you will see the same set of things. The top 10 vulnerabilities like this API security, cloud security, or application security. It is all standard. Broken object, right? Broken authentication. I connect to the system. My session information is taken over by the man in the middle, and I lose access to the system, or they have my access information. Next time onwards, they will try to connect to the system. Just to have an understanding of all these things. Okay, so I mentioned about this OWASP, right? It is one of the organizations that constantly publishes what are the top 10 vulnerabilities, and I mentioned it mostly remain the same over the years. It doesn't change much. Okay, injection attacks, right? So the injection could be in database or internet. What does it do? It tries to manipulate the data. Like I said, I am trying to fetch my marks, and I might get the result of somebody else also, because there is somebody who is manipulating the data in the internet as I access the system this way, or they might download all the other users data. Okay, so SQL injection attack is one of the most prevailing attack, and this could lead to remote code execution is like I mentioned, because your information is there in the internet. For example, now everybody has access to their own system. In the past, when I was using, we used to go to the internet cafes, okay, because we don't have access, right? And in the internet cafe, what will everybody will use the same system, and I may not have cleared the cache. I will simply log out and come out, but the cache might still be available. So that is where this remote code execution, right? You go to the internet cafe, you download your mark sheet, come back, but this is information available, and that information can be manipulated, and they will download all the data. We talked of broken authentication and session, because so this is one of the important things as you develop applications, right? Session management. For example, you get timeout, right? You stay idle when you are connected to the banking system or anything, you get timed out. After if you are inactive, the system will automatically shut down, because your session cannot be open, because it is vulnerable and anybody else can use that system to access. So this is session management is very, very important. And right, for example, broken authentication, you have your passwords in the plain text, it is vulnerable, right? And this one is called the cross-site scripting. Cross-site scripting, like for example, some of the activities are done in your browser, right, in the local machine, and certain portions of the application gets rendered by the server, right? So what will happen is you have your application, you develop your application. If there is a flaw in that, for example, there's something you will learn. You may want to do more exploration on cross-site scripting. This is one of the prevailing vulnerability. So the hackers, or the malicious people, what they will do is they will inject some portion into your application, okay, and that will get downloaded into the client side of things. Instead of the intended script running, the malicious script will run, and that may lead to point to a different website. Okay, you might think you are accessing the genuine system, but it's a false system. You will be taken to a different system. In that process, the malicious person gets access to your data. What is the user ID, password, all those stuff. So it is, again, like I mentioned, it is an injection attack that involves injecting malicious scripts into web pages in order to execute code in the browser. And this can lead to session hijacking, data theft, and all those stuff. So cross-site scripting is one of the most prevailing vulnerability even today. Again, broken access control, because if I don't properly authenticate, right, that could lead to my access control. For example, bypassing access control mechanism. So if my access control authentication process is not strong, anybody can get access to the system. Security misconfiguration. For example, when an application is improperly configured and opens security, like I said, 65,536 ports are there. If I open unnecessary ports, or if I don't close the port, for example, you open the door as you enter. If you don't close the door, it is vulnerable. The same thing, any misconfiguration, disabled security settings, okay, incorrect file permissions. It's a simple example, right? So if I am giving a wrong permission to user, then it is, you are bound to have, the damages caused. So these are the first 5, and again, if you see, you will always see an overlap of what we talk of, because why it is all repeated, because you have to know these are the things that cause damages. It is not something new that is happening in the industry or something like that. Because people fail to take control of these things due to oversight or due to time bound restriction or something like that, there will always be a chance. Like I said, your own application or a third party application or any API that you try to use, wherever the vulnerability, your system will get impacted. Insufficient authorization and authentication, we talked of it, right? Insecure cryptographic storage. For example, like I said, your passwords. If you store your password in a plain text, it is the easiest thing for a hacker, right? That is what cryptographic storage. So you have to use a strong encryption algorithm. You don't use a simple, and that's where you see a 128-bit encryption, right? You can see even in your mobile also, sometimes it will say we use a 128-bit encryption, 256-bit encryption, all those stuff. Tampering with the data, like I said, insiders or anybody, if they have access to the system, the administrator is supposed to manage the systems. If that administrator intently want to do some damage, they can do, right? So they can update a database if they have. So even if you are a database administrator, that's where auditing and logging is very important. You have database administrators in your, for example, if somebody is managing your marks database, if that person is given endless privilege, at his will he can do anything, right? You are a friend, he will do. So you have to audit, you have to log how many transactions, what is it, okay, and that has to be supervised, that has to be analyzed. You have data analytics tools nowadays, okay. For example, only during the for example, the results publishing stage, somebody needs to access that system. If there is an access to that system prior to that or after that, then you need to immediately raise a question, why this system was accessed. So tampering with data is very, very important. Using components with known vulnerabilities. For example, this is again one of the easiest thing could happen. Everybody wants to develop a software, or you may want to develop your own web application. You want to develop your own website portal. What do? You go to Google, you find out what are the open source tools. You use a MySQL database, use Apache web server. Everything is free. There is a subtle difference between free and open source. It's more from the license perspective. So what do? It gives you immediate access to the development tools and technologies, you develop it. You don't understand about who is responsible for any vulnerability in the software. If there is a flaw, because it's done by the community contributes, right? There is no single owner who, if you are using Microsoft product, at least you will get a patch. In the community world, who provides the patch? Only the community. So you have to understand what are the vulnerabilities in the known things. What is the vulnerability in this particular version of MySQL, in this particular version of Nginx? So you need to clearly understand that. And the most important, and which I talked of also, is the insufficient logging and monitoring. Unless you log every transaction, every access, every activity, you cannot monitor. So what doesn't get monitored, you cannot take corrective actions. Only when you come to know of somebody has tried to access my system, then you will raise a question of what made them to enter into our system. Is there a gap in our system? Is our authentication mechanism poor? So logging and monitoring is very, very important. That's where you see most of the organizations today, they fall into two categories. One, people who know their systems got hacked and they have taken corrective actions. The second group, they don't know their systems have been hacked and they are still using the same system. So continuous logging and monitoring, it's very, very important. So how do we mitigate against these top 10 vulnerabilities? Okay. This is the recent one of late, people have been talking even during COVID time. Zero trust security. Zero trust security is like, I don't believe in anything. I don't trust with your initial level of authentication alone. Every point of entry, I will raise a question whether you are a genuine user. First level, network access control, that's called NAC, right? At the network stage itself, that is my first point of entry into my corporate network, firewall, right? That will detect. Second thing, authentication to the user ID password to the system, server. Third thing, I want to access an application, whether I am authorized. So you continuously question your credibility. That's called the zero trust security. The second one is the web application firewall. The web application firewall technology has evolved so much. Today it can, probably help you a lot. That will constantly monitor, like we mentioned about cross-site scripting. So web application firewall will try to find out if DDoS attack is happening. Okay, if there is a different pattern, whether access pattern is different now. For example, any corporate website, for example, that could be a pattern. That website could be more active in the evening time or in the morning time. So if it sees a different pattern, then it will automatically alert. So web application firewall has, for example, more of continuously monitor the traffic, and it will block also. You can put a control saying that if I am getting more than 100 requests per second, because my website used to get only 50 to 70 requests per second, it is getting more than 200 requests a second, it will block. So how it works is different. And password policy and multi-factor authentication. So these are simple steps, but that will ensure your systems are safe and secure. Data encryption we talked about, access control we talked about, input validation. This is one of the fundamental things that every developer should ensure. For example, password. As I type the password, there has to be a policy, right? Password should be more than 8 characters. Has it got special characters in that? Whether I am using a repeated password, the same last 3 passwords. Every organization puts this control. You might have seen it in your banking also, right? So input validation is that am I entering anything special? SQL injection attack, that probably I don't have an example. SQL injection attack, you can see when I say select or where, all those conditions, and if people put some special characters into that, that will cause a damage. In a web application, we talked about cross-site scripting. So if there is any place where I am using a less than symbol, script greater than symbol, if there is a script portion in mind, you need to validate whether somebody is putting a script. If that is there, then what is the control that I have to find out that and mitigate it. The input validation is one of the must And hygiene, cyber hygiene is, it's like daily or physical thing. There has to be discipline, policies, procedures, standards, guidelines. You need to have training, awareness. These things will ensure that you are minimizing your damage. Effective logging and monitoring we talked about. Okay, everything has to be logged. Okay, it's not about whether I have the storage or not that much of storage. Everything has to be logged, right? That's where for example, if I have a biometric system, that is the entry point that gets logged. Then for example, I have to go to the data center. Okay, then I have a retina scan. Okay, that has to be logged, and these things to be monitored. It's not about logging; it has to be monitored, and somebody should review this whatever the data that's logged. There are tools and technologies for automatic monitoring, but that has to be monitored. Okay, because not every system is fail proof, right? Biometrics can be easily overcome. So everything has to be logged and monitored. Like I said, regular scanning, audits. You are introducing new server into the system. Okay, in the context of business urging you to deploy the system, we want to go live tomorrow because there is a new offer, $1 billion sale. We have seen that, right? Big billions and all that stuff. Then it requires hundreds of systems to be immediately deployed just for that one day. In that process, you make a mistake, you oversight, some oversight happens. That's it. That is enough for people. So this penetration testing, audit, all those things. And finally, the secure coding practices. How you develop your system is very, very important. Whether my developer, it doesn't matter whether I'm a fresher, whether I have a 3 years experience developer, 6 year experience architect, it is immaterial. We are all humans, we will make mistakes, right? That's where I talked about shift left testing. The developer has to develop with the security mindset. You need, how do you understand what is the security from your perspective, right? So there will be guidelines, standards, procedure. Hey, this is how the system should be developed. Okay, you write in SQL query. How do you find out? This is SQL injection proof, right? This is cross-site scripting proof. Okay, you do it. You develop the application. You test it. It's more like a self-certification. You certify. This is what I have developed. That is where you eliminate the portion of the operations team taking ownership for the code you developed, right? Because otherwise it will become a blame game. Hey, I have developed my system. It is only in the deployment process something got changed. No, that this will ensure that almost the top 10 vulnerabilities can be overcome. And still organizations make mistakes. Organizations do face problems. So if I'm fine. No, if you feel that I'm rushing through things or you have something, I'm always available. I'll share my email ID. Any personal thing you want to understand or how do you want to study some of these things, and maybe I'll put it now. Ma'am mentioned about the cybersecurity newsletter. I was unable to publish this month's newsletter in LinkedIn. So you go to my LinkedIn page. I started after my CSSP certification. I wanted to see how I can help out people to understand this domain. I'm just publishing. It's not a comprehensive. Maybe over the time, you will find it quite useful. I have written 3-4 months. I have written. This month I haven't. I'll take time to publish it before this month. So this is an interesting field, interesting domain. It will make you curious to know things, where things could go wrong. See, there are different things. Don't think of ethical hacking, white hat, gray hat, black hat, all those. Don't confuse it with the cybersecurity things. Okay, that is to identify the gaps. This is a complex. This is a superset view. You see it from 30,000 feet. Okay, the goal of a cybersecurity professional is not to find where the things go wrong. It is to find out where and all the vulnerabilities exist. What should you do? How do you protect? How do you minimize the risk? That's it. How do you, what do you deploy? How do you deploy? That is the operations portion of it. But for you to have an understanding of, you need to have an understanding of all those things: development, deployment, management, security, networks, operations, AI, ML, everything. Okay. So this is, because this will make you, more interested, because you understand most of the things that cover the, right from the internet, how internet works, through applications, through systems, through third-party systems, integration of the system. That's called the systems integration, right? So it's a quite interesting field. So we'll have a break, right?